Here we can see three incredibly important items. The two essentials of any manned spaceflight are, of course, a rocket and a spacecraft. The big bell-shaped object you can see in front of you is a re-entry capsule that carries astronauts to space and back. When traveling in space, this capsule also serves as a control room. Many people think astronauts sit inside this capsule. In actual fact, they lie in their seats during liftoff and their flight through space. The reason for this is to prevent blood from concentrating in their lower limbs due to their rocket's high-speed acceleration. Were blood to begin pooling low in their bodies, the astronauts' brains would be so starved of nutrients and oxygen, they would quickly lose consciousness and eventually die. Here you can see the intravehicular spacesuit Chinese engineers made for astronauts to wear inside their cabins while in space. Interestingly, when astronaut Zhai Zhigang took off in Shenzhou 7 in September 2008, the spacesuit he wore was an extravehicular one for use outside the ship. The reason being that Zhai Zhigang's trip aboard China's third manned spaceflight would see him embark on the country's first-ever spacewalk. Why are intravehicular spacesuits different to extravehicular spacesuits? When a rocket lifts off, the air pressure in its cabin will drop rapidly as it soars higher and higher into the stratosphere. If the mission's cabin air pressurization control suffers a problem, such as a pressure leak, the astronauts on board will be in danger. In one past accident, a Russian cosmonaut died because of such cabin depressurization. Intravehicular spacesuits are designed to keep their wearers completely airtight and protected from the environment outside. The ventilator that astronauts carry into the spacecraft cabin will blow air into the suit to keep air pressure inside at the normal levels wearers are used to back on Earth. Intravehicular spacesuits include thermostats, are humidity-proofed, and capable of allowing astronauts to excrete solid and liquid waste. The big secret that unites space travelers of all nationalities? They all wear baby-style diapers during their mission's liftoffs and re-entries. Look up, and high above us, you can see one of the gigantic parachutes space missions use to safely return astronauts' re-entry capsules to Earth. While a spacecraft normally takes around 8 minutes to escape the Earth's gravitational pull, its return to Earth must be much slower, or the rapid change in cabin pressure will kill the astronauts inside. Parachutes like this significantly slow quick-falling re-entry capsules. Each capsule is also equipped with 2 other auxiliary chutes. In addition to a small guide parachute, there is a medium-sized parachute that reduces the craft's return speed to a suitable level before the main chute opens. As you can see, this deceleration parachute is huge, measuring around 1,200 square meters. Ultimately, only such a vast chute can slow and soften landings. You are probably asking yourself if a real parachute would have so many holes in it. The fact is that chutes of this size will encounter tremendous air resistance during descent. Without these holes, the parachute and return capsule will swing or wobble dangerously, seriously injuring the astronauts inside. Can you also see the many thrusters underneath the capsule? They are used to generate the thrust that pushes the capsule back up into the air when it reaches a height of about just 1 meter before final touchdown. This one last air cushion will make sure astronauts' landing is a soft and safe one. As you can see, the thinking needed to explore the stars is incredibly complicated.